friends, welcome back to our channel Concept with Clarity 1. In this lecture we will try to implement half adder and full adder using transmission gates. To start with the half adder, like we have the block diagram, we have two inputs A and B and two outputs sum and the carry. The output equation for sum is A XOR B and also the output equation for the carry is A and B. So if you look at the implementation, right, both are, one is XOR gate and the other one is AND gate, simple AND gate. Okay, so we have already implemented the logic gates in the previous lecture. We have already implemented the logic gates using transmission gates. Okay, so what we will do is we will try to club these things and we will give the common input to the a common input A and B, and we will take the outputs, two outputs sum and carry, right. So what we will do, first of all, to implement an XOR gate, we will see how to implement it. So I will draw, first of all I will draw my basic transmission gate, okay, with which I can draw the logic gates. You can see here, so this is Y, right, and this is A and this is A bar and this is also A bar, right. So for an XOR gate, what is the output? A, B, Y, 0 0 0 1 1 0 1 1. So it is 0 1 1 0, correct. So you can see here one of the input is B and one of the input is B bar here, correct. So this is, I don't write it as Y, it is simply sum, okay, because sum is equals to A XOR B, correct. Next, and to just you can see here, first of all, now what do we need? Here I can see a term called B bar, right, a term called B bar. How to implement this B bar? This B bar, simply it can be implemented by using CMOS logic. You can see, so one combination of one PMOS and one NMOS transistor. Okay, this is simple CMOS inverter, correct. So this will be input B and here I will be connecting this thing, this is VDD, right. So this is my B bar. How to generate a B bar and how to generate an A bar can be seen here, right. So for an A, again I will be taking, okay, this is B and this is ground and this is A bar, right. So this is the implementation of this sum. Okay, similarly we can implement a carry as well. Okay, how to implement a carry? How to implement a carry is nothing but, so it is also simple transmission gate, a simple transmission gate. This is a PMOS, right. So if it is an NMOS, then this will be a PMOS. Okay, so this is NMOS and this is connected here. This will be carry. So one of my input is A and if it is A, this will be A bar and A bar. So what is AND gate? What is AND gate is nothing but A, B, Y, 0 0 0 1 1 0 and 1 1. So what is 0 0 0 1, right. So one is grounded and the other one is nothing but B input. Okay, common inputs, right, common input should go. So if it is A, then I need to basically drag it from here, correct, and if the input is B here, basically we will be dragging it from the wiring. Okay, so we need to give the common inputs here. This is how you implement an half adder using transmission gates. Here in the transmission gates we are using two transmission gates, TG1 and TG2, and also two CMOS inverters, right, two CMOS inverters we are using for the implementation of A bar and B bar, right. So this is the implementation of an half adder using transmission gates. Next, what we will do, is we will try to implement an full adder using transmission gates. Okay, now this is bit tough. Okay, now let us try to understand. Okay, for an full adder we have 3 inputs, A, B, C in, and 2 outputs, one is sum and one is C out. Correct. I will try to draw without using carry propagate or carry propagate. Okay, carry generate and carry propagate. I will try to draw with direct logic. Okay, by using direct equations. We have 2 equations, right? One is sum is A XOR B XOR C in, right? And C out is equals to AB plus BC in plus AC in. 2 equations, right? First of all, let us implement this sum and then we will implement an C out. Okay, only thing what we have to do is we need to have the common inputs. Okay, A and B only from one source, right? So you can see here, so we'll start drawing now for sum. Okay, so let us take sum is equals to, I have A XOR B XOR C in. Let A XOR B is equals to X, if this is equal to X, right? Then sum will be equal to X XOR C in, right? Now to implement this one, I have a simple, by using transmission gates we can implement, right? So how I can implement? So I will be using the transmission gates for an XOR gate. This is right. Okay, I will connect these things and I will tell this as sum. Okay, so if I take, what is this one? This one equation, you can see this will be X bar into C in plus X into C in bar, right? So if I take C in here, if you see here, this will be equal to, if I take C in, if C in is equals to 0, then X will be my output, and since C in is equals to 1, X bar will be my output. So this will be C in bar, this will be C in bar. Okay, now what is our X? X is nothing but A XOR B. So again I will be having one XOR gate here, okay. So one of the inputs will be A and I will connect this X as like this, okay, and if it is A, this will be A bar and this also will be A bar, and you can see here for an XOR gate this will be B and this will be B bar, correct. So how simple it is. We know how to implement an XOR gate using a transmission gate. Okay, so what we will do is nothing but, here I need to give an X bar. Again I will do is I will take an inverter. CMOS inverter. Okay, the output is connected here. This will be given to VDD and the input will be X. So X bar will be my output. Okay, similarly we can have CMOS inverters for getting A bar, C in bar, right, and the other things also. Okay, so basically this is the implementation of the full adder using transmission gate. Okay, not the complete full adder, it is the sum implementation. Similarly we can implement this is sum. Okay, similarly I can implement the carry out also, the C out. C out is equals to AB plus BC in plus AC in. So what I will do is I will make use of, for AB I will use one implemented two transmission gates, and addition of this one here, and addition of this one here. Okay, so multi-level implementation we will do here, right? So first of all, what we will try to do is, you see here, first let us try to implement AB. AB. Okay, so let this be A into B. For A into B, this will be A, this is A bar, this is A bar, and for an AND gate you can see this is A B Y 0 0 0 1 1 0 1 1. So it is 0 0 0 1. So if I divide, this will is grounded, and this input is nothing but B, correct? Similarly, I can have the other one. For B into C in, for B into C in, you can have another transmission gate. So this will be B into C in, and if this is B, and this will be B bar, and this will be B bar. For B into C in, this is again grounded, so this will be equal to C in, right? Next, in the third case, it is AC in. One transmission gate here, another transmission gate here, right? I will connect this. This is A into C in. Okay, so if I take it as A, this will be A bar, this will be A bar, and this is grounded, this will be C in, right? A into C in. Okay, so this is the implementation. You can see 1 2 3 transmission gates and 3 OR gates we have got now. Now what I will do is, I will add first this thing, okay, and the output of that I will try to connect with the another, this is output ACN, right? So for that, you can see here, I can use, another transmission gate here. So this will be AB plus BC in. Okay, so now you see here, for suppose if I connect AB as one of my inputs here, then what should be my inputs here? Then this will be equal to AB bar, this will be equal to AB bar, right? Now what will be the input here? This is an OR gate. OR gate means 0 0 0 1 1 0 1 1 0 1 1, right? OR gate means this will be equal to B and this will be equal to VCC. So this is plus 5 volts and this will be equal to BC in. Right, BC in is connected directly. So this will be AB plus BC in. Okay. Now what we will do is, we will try to connect the outputs of AB plus BC in and AC in. For that, another transmission gate I will take. Okay, in multi-level we can draw. So this is the final C out. Okay. So one input. Here I wanted to take the input as AB plus BC in. So this will be AB plus BC in whole bar, and this will be AB plus BC in whole bar, right? So what will be this? Because this is OR gate, this will be connected to plus 5 volts and this input is connected to AC. So you can see once again here in the first level we have AB and and we have BC in and AC in, right? And what I have done, I have added AB plus BC in, and I have added this one to AB plus BC in plus AC in. That gives my V out, correct? That gives my V out. Okay, I hope you understood the concept of implementation of full adder using transmission gates, right? So if you understood the concept, then please like the video, share and subscribe the channel. Thank you for watching.